work yesterday, but then I finally did. All right, so we are going to go ahead and get started. Today is the last new day of the chapter. And I was telling first hour today that we have to be at the same spot at the end of the semester as my classes and Mr. Seifbert's classes in the fall. And before today, we had probably 2 days to play with, 2 extra days. And so I asked first hour if they would rather have an extra review day for the test. And they said they would. Are you guys okay with that?
Well,
Okay.
what else will we use the day for?
I don't know.
Oh, okay.
Yeah.
We're ahead of them.
We're ahead, yes, by 2 days. So what I said is the assignment I'm giving you tomorrow is going to be 10 points extra credit on your test. So when I give that to you tomorrow, you guys won't turn it in until the day of the test. And then you'll just bring it to class. I'll write plus 10 on the top of your test if you did it, okay? So that's kind of what I decided to do with that. Okay, so today we are going to learn how to graph and solve quadratic inequalities. And a quadratic inequality is something that has an x squared, okay, so something like this, and it has a greater than or less than or greater than and equal to, less than or equal to sign. And there's 3 different types of problems that we are going to be doing today. And then the way that I do the homework is that the homework I kind of give in 3 sections, so you'll know exactly which type is which type of problem, okay? So the first type that we're gonna have today is where we're gonna have an inequality. Oh, and this y should not be squared actually. It would be like this. We're gonna have an inequality that has a y in it. The second and third type that we're going to be doing is going to have a 0 in place of the y. So in this one, what you're solving for is what ordered pairs work in this inequality. In this one, you're solving just what x's work in this inequality, okay? So there's 2 different types that we're going to be doing. Just to kind of explain how you would do this, we're going to graph parabolas just like we did at the beginning of chapter 3, okay? So that's a good review of how we did that. We're going to graph them. The difference is if it's a less than or greater than sign, you're going to have a dashed line on your parabola, which I always forget to do. I always draw them solid. So try to remind me if I forget. If it's just a less than or greater than, it has to be a dashed line. If it's less than and equal to or greater than or equal to, then you have a solid line for your parabola. Now, in the first section, that's what we did. We just graphed that parabola. But today, it's an inequality. And so what we're going to be looking for is what points solve that inequality. And when it's a parabola, it's either going to be a point inside or a point outside that we're going to check. And say we pick the origin. Oh, no, our origin is over here. Let's just say we picked this point, -3,0, in the inequality, and we checked it, and it worked. Then we would shade inside the parabola. If we picked a point outside like 0, 0, and it did not work, then that would tell us don't shade here, shade inside. So you can pick a point inside or outside. If you pick inside and it works, that's where you shade. If you pick outside and it works, that's where you shade. Okay? So let's go ahead and get started. So we've done a lot of this already. So if you guys remember, first of all, it's going to ask you, should it be solid or should it be dashed? And do you guys get that it would be dashed? So hopefully I will remember. I never remember this, but I will try my best to remember that. Then we're going to find that axis of symmetry, just like we did at the beginning. And A, again, is what's in front of your x squared, which is 1. B is what's in front of your x, which is 2. And C is your constant, which is 1. And then we're going to find that x, which is negative b, and b is 2, all over 2 times a, which is 1. So this is negative 2 over 2, which is negative 1. So one of the things you're going to do on these today is somewhere by your graph, tell me what your axis of symmetry is. So this will be part of your answer. And then you're going to go to your graph at x equals negative 1. And draw that axis of symmetry. Okay. Then what that also tells you, if you remember from back when we did this, whatever this is, that negative 1, you kind of put in the middle of your x's that you're solving. And then I always do 1 less than that. Oh, sorry. 1 less than negative 1 is negative 2, and 1 less than that is negative 3. And then I do 1 larger than that and another 1 larger than that. Now there's 2 different ways you can get those. There's actually 3 ways. You could put those into your inequality and just work it out by hand. You could put them into your inequality on your calculator. And if you remember, we'd put it in and then we'd go second enter, so that would come down again, and we'd go back in and change whatever was in parentheses. Do you guys remember what I'm talking about? Okay. Or the third way you can do it is you can graph it and make a table on the graph. So I think I'm going to show you it that way. So here's what we're going to do. We're going to open up our calculator. So if you guys want to grab yours, we're going to go to y equals, and we're going to graph that equation. Okay. So clear whatever you have there, and this is x squared plus 2x plus 1, and you can graph it so you can see what it looks like, okay? But I'm using this more for my points in my table. So what I'm going to do is go second table set. And if you look back here, we started our table at -3 and we counted by 1s, okay? So if I go back, what I want to start my table with is a -3, and I'm always going to count by 1, so you don't have to change that. And these are both auto, okay?
Wait, how'd you get there?
Second window.
Oh, okay.
Yep. And I never change this or this. I only change what I'm starting that table with. Then to get to the actual table, you go second graph, and these first 5 things are my table values, okay? So -3 is 4, then it's 1, 0, 1, 4, okay? So back here, it's 4, 0, or 4, 1, 0, 1, 4. Everybody understand that? Okay. Now we're going to go and plot these points. So at -3, I'm up to 4. At -2, I'm at 1. At -1, I'm at 0. At 0, I'm at 1. At 1, I'm at 4. And remember, you have to do a dashed parabola when you do this. So you're just going to kind of estimate where you think it's going to go. Something like that. Okay. So now we have our parabola, and what we're gonna do is we're also gonna label what our vertex of it is. And our vertex is gonna be this point, which is also this bottom minimum point. So it's just -1, 0. So that's another thing I want you to say in these, okay? And then the last thing we do is we have to choose a point, either inside the parabola or outside the parabola, to see if that point satisfies the inequality, and then that will tell us where to shade. Now, if I ever have the origin that I can choose from, I choose that. And the only way that the origin would not be a point you could choose is if the origin was a part of the parabola. Like I couldn't choose the point -1, 0. I couldn't choose the point 0, 1 or -2, 1. As long as it's not on the parabola, I can choose that point. And if I ever have the choice of 0, 0, I choose that. So what I'm gonna do is try 0, 0 in my inequality, which is y is greater than x squared plus 2x plus 1. Okay, so what I'm going to do, in for y, I put 0, and my x's, I put 0. Now the reason that 0, 0 is a good one to do is that this is going to end up to be 0, and this is 0. And 0 plus 0 plus 1 is 1. Okay, so what you're going to ask yourself there is 0 greater than 1? And it's not, right? So what that tells you is that 0, 0 does not work. So that means if I tried any point outside of my parabola, it would not work. And where I should be shading is inside my parabola. And if you're on the test and you're like, I just want to make sure that what I chose is correctly or where I'm shading is right, since this didn't work, you could try a point anywhere inside of here and make sure that it works. Like you could try the point -1, 2 and make sure that it works in that inequality, okay? But we're gonna assume that we did that right, and we're gonna shade inside here. Okay, and that is your answer. And so make sure you always get the axis of symmetry and the vertex. Okay, so now let's go to this one. Should this one be solid or dashed?
Solid.
Solid, because of that equal. Good. Now here, A is what's in front of your x squared, which is 1. B is what's in front of your x, which is -8. And C is your constant, which is 16. And then we're going to find x. The axis of symmetry is going to be -b, which is minus a -8, all over 2 times a, which is 2 times 1. A minus a -8 is a positive 8 over 2, which is 4. So what that means, my axis of symmetry is x equals 4. Okay, and then I can come down here and at 4, you can either do a solid line or a dashed line here, whatever you'd rather do. So that's your axis of symmetry, okay? Now, that also tells us, if this is 4, that tells us that's what should go halfway through my table. And then I should have 1 point smaller than 4 and 1 point smaller than 3. And then 1 bigger than 4 is 5, 1 bigger than 5 is 6, and those are my values, okay? So now I am going to go back and put this graph, this equation, into my graph. And You don't have to reset your table each time. You certainly can. So I'll explain that as we get into that. So let's go here and go to y equals and clear what you have in there and put this new equation this time, which is x squared minus 8x plus 16, okay? And what I'm gonna do, I can hit graph to see what that looks like. And here's what I was saying about the table set. You don't have to change it every time. We want our table to start with 2, and I could certainly switch my table to see that, but I could also just do second window. Oh, that would change it. Ignore that, sorry. Go second graph, and you can just look at your table and go down to 2, and it's going to be these 5 points. If you would rather do that table set and have it start with 2, you can do that. You can go second window, put a 2 here, and then go second graph, and then your points are right up at the top. Okay? So again, this time we're getting the points 4, 1, 0, 1, 4, which is what we got the first time also. So 4, 1, 0, 1, 4. This is my vertex. So we're going to write that down. Okay. And then I'm going to go ahead and graph those points. So at 2, I'm up to positive 4. At 3, I'm at 1. At 4, I'm at 0. At 5, I'm at 1. At 6, I'm at 4. And we talked about how this is going to be a solid parabola. Okay? All right. Then what we're going to do is pick a point that is not on the parabola. It can either be inside the parabola or outside the parabola, and see if that point works in our equation. And again, I can try 0, 0 again, just because that's an easy one to deal with. So I'm going to try 0, 0. And my equation is y is less than or equal to x squared minus 8x plus 16. And I'm going to try putting 0 in for y, as well as 0 in everywhere I see an x. Okay. Now 0 squared is 0, minus 8 times 0 is 0, and 0 plus 16 is 16. Is 0 less than or equal to 16? Yes. So what that tells me, since this point is outside of the parabola, that tells me that, I'm going to get a highlighter here somehow. I can't remember how I do this. Is it this? No. Here maybe. Yes. Okay. So what we can do there is shade everything out. Oh, that didn't work. Everything outside of here. So let's try that again. Maybe I'll just try my finger. Okay. So it's going to be everywhere except for inside the parabola. Okay? That would be your answer. Okay? All right, so let's go to this page. So the first 2 examples we did are where you had y in the equation, and whenever that happens, you're going to be, your answers are either going to be everything on the graph outside of the parabola or inside the parabola, okay? The other type of question that we're going to get is where we don't have a y. And what happens there, the only thing you're solving for on this is we're solving for the x's. You're never gonna have a coordinate that's off the x-axis. You're just looking for what x's does this work for, okay? So how we get started is there's a couple of ways you can do this. You could, if we went back to the rules, you have to find those zeros, which are the x-intercepts. And when you find them, you can find them by graphing. You can find them by factoring it, which some of these are easy to factor. And if you could factor it to find the zeros easier than using your calculator, you can do that. You could complete the square. People probably wouldn't choose that, but you could. And you can use the quadratic formula, which once I give you the quadratic formula on your calculators, you'll probably choose that.
Why?
Okay?
That's why you're waiting till the end of the unit to give us that.
Because on the test, I want you to do the quadratic formula by hand.
Okay.
Yeah. Okay, so here's what we're gonna do. Our A is gonna equal 1, our B is 2, our C is -8, okay? And then what we're gonna do is, actually, I didn't even really need to do that this time because we are not doing that x equals -b over 2a. We are just gonna plot this on our calculator, okay? So let's go to our calculator and plug this in. So I'm choosing to use my calculator to find two things. I wanna find the minimum or maximum value, and I wanna find the zeros. Okay, so first let's put it in, and I get x squared plus 2x subtract 8 graph. Now somebody said today that their graphs look different than mine. That could be because I have a little bit different window. And so like really if your parabola fits in it, it's good to do zoom 6. I think my window was just set up differently. Then what we're gonna do is we're gonna find 3 points. Do you guys get for this, the vertex is gonna be the minimum since it opens up. If it opens down, we would find the maximum. So the first thing I'm gonna do is find that minimum. So to do that, I go second trace. To find the minimum, I go down to number 3. And then I want to move my cursor so it's to the left of that minimum and hit enter. Move it so it's to the right and hit enter. And then hit enter again. So here's something that happens on your calculator. Sometimes the point is exactly -1, but your calculator will say like -1.000000 something. That means it's close to that. In fact, somebody this morning had, for theirs, they had 1e to the -12. What that means is 1 times 10 to the -12. Which is 0.11 zeros and then a 1. So what that means is that number is really, really, really close to 0. So they mean it's 0. For some reason, our calculators don't always round to that nearest number when it should be, okay? So if it's like a string of zeros, you can just assume that's -1.0 or -1. Okay. So our minimum value is -1, -9. So we're gonna write that. Well, I should probably just write minimum. So my minimum is -1, -9. And I'm gonna come here and go -1 down to 9, and that is my vertex. Yes. On these, you have to sketch the minimum and maximum, or maximum and the x-intercepts, okay? So now we are going to come back here, and I have to find what these x-intercepts are. It looks to me like this goes through at -4 and that goes through at 2, but I'm just gonna make sure. So I'd go second, trace again, down to 0. Move this so it's to the left of the first 0. Move it so it's to the right of the first 0, and then hit enter again, and that is at -4. Okay, so that's one of my x-intercepts. So at -4, I have an x-intercept. Then if I go back, I'm gonna again go second calc down to 0, and I'm gonna move my cursor so it's to the left of the second 0. Move it again so it's to the right of the second 0. Guess, just hitting enter, and that is an x-intercept at 2. So what that tells me then is it goes through my x-axis at -4 and 2. This is part of your answer, okay? And then you have these points, oops, and is this one solid or dashed? Dashed. So these we're just going to use the minimum or maximum value, and we're going to use the x-intercepts, okay? Now, what happens here, once you get that graphed, is we only care what x values this is solved for. We don't care about the y's. So either this section and this section are going to work, because it's either that your middle part works or it's that the outside 2 parts work. So if you chose a point in the middle, which if we chose 0, okay, and we put that in here, let's try that. Let's try x equals 0. Okay, and if I put that in, I'd get 0 squared plus 2 times 0 minus 8. Is that less than 0? This is 0 plus 0 minus 8 is -8. Is -8 less than 0? Yes. So then what you can assume then is that it's graphed in between here. And another thing, this is more like almost using a number line. If this is less than or greater than, you actually have open circles on the ends. Because these points are not included, that's why this is dashed. So now, what they ask you for is to write your solution set. What that is what x's does this work for? And what it works for is our x's between -4 and 2. So this is how you write it. -4 and 2, you always put your smaller one here, bigger one here. X in the middle. Your signs are always less than. If these are closed circles, which they're not, but if they were, you'd have greater than and equal to signs, but we don't because ours is open circles here. So these are the x's that would work in our equation. This is our answer.
It's always less than?
Yes, if you put the smaller one here and the bigger one here, they're always less than. Yes. Okay.
Where did you get the green one?
I chose 0, 0, and it worked. So that means, because what you're checking, do you need to fill this in?
Like, yeah, like,
Yeah, you're either going to have this shaded or the outside 2 shaded. So I tried x equals 0 and it worked. So that means it's shaded inside. If it's shaded inside, that means it's not shaded outside. If it's shaded outside, that means it's not shaded inside. Does that make sense?
What happens if it didn't work?
What's that?
If it didn't work, if 0 didn't work?
If 0 didn't work, you can assume that it's going to be shaded in these 2.
So
Or what
just
is
those
that
two
little-
lines,
Yep,
So
and
you
then I'll show you what that looks
so you
like
have
on our next problem.
two separate solutions.
We'd have two different solution sets, and our next one is like that, so you'll see it. Okay?
And wait, how
Yep.
do you know if they're closed circles or open circles?
Okay, good question. That has to do with this. If it's less than or greater than, they're open circles. If it was less than and equal to or greater than or equal to, then it's closed circles. Okay? All right, so let's go and try another one. So again, let's plug this into our calculator. 2x squared plus 4x minus 5. So I'm going to go to y equals and go 2x squared plus 4x subtract 5. And I can hit graph just to see kind of what it looks like. And then what I want to do is check where is my minimum or maximum. And do you guys agree this is going to be a minimum because it's opening up? If it was opening down, I'd be finding the maximum. Okay, so I'm going to go second trace and find my minimum value. I'm going to go down to 3, and then I'm going to move my left arrow so I'm to the left of this minimum. And then I'm going to move the right arrow so I'm to the right of the minimum. And then I just hit enter again. Now this one is one of those examples where this says negative 0.999999999. What it really is close to then is what? Negative 1, okay? So if it's like that where you have a string of 9s or you have a string of 0s, you can assume that this is really negative 1, negative 7, okay? So let's go back. Our vertex then, which is our minimum in this case, you could label this as either of these. They're really the same. So negative 1, negative 7. So I can go on my graph and go negative 1, negative 7, and put that point. Now I need to find where does it cross the x-axis? Where are those zeros?
How do you know it's negative 7?
From here.
Oh.
Negative 1, negative 7, okay? Then I'm going to go back to my graph and I'm going to do the zeros. So to do that, I go second trace down to 0, move this to the left of the first 0, move it to the right of the first 0, and hit enter again. Now this one is not a whole number, and this is what I was talking about. Do you see how this is negative 1 times 10 to the negative second? Okay, that is like 0.11 zeros. So imagine 11 zeros here, and then a 1. Oh, and then I got off of that. So what do you think that's really close to? 0, okay? So this 0 would be at negative 2.870, okay? Which is that point right there. So my x-intercepts are at negative 2.87, which I can graph, just kind of estimate like 2.87, maybe somewhere like that. Okay, then my other x-intercept, I can go back here, I can go second trace down to number 2, move this so it's to the left of the first 0, move it so it's to the right of the first 0, hit enter again, and now this one is at 0.870. So that is your other x-intercept, is positive 0.87, which would be almost to 1. Now I have my vertex down here, and I'm using those 3 points to make my parabola. And I should have asked this, but do you guys get that it should be solid because it has that greater than?
Yeah.
Okay. Now what you're gonna do is check a point. If you can check a point inside like 0, 0, if I can ever check 0, 0, that's what I do. And that's what I'm gonna try here. If this works, do you guys get that you'd shade inside? If it doesn't work, you're gonna shade all outside. Oh, but we're just doing the x-axis on this one. So you'd shade here if it works, you'd shade here and here if it doesn't.
It would only not work to check 0 if 0 is like on the line.
On the parabola. If 0 is part of your parabola, you cannot choose 0. Good question. Okay, so let's try this. We're gonna try 0. So we're gonna put 0 in there. 2 times 0 squared plus 4 times 0 minus 5 is greater than or equal to 0. And you don't have to write this out. You guys will probably just look and say, this is 0, this is 0. 0 plus 0 is negative 5. Is negative 5 greater than or equal to 0? No, right? So that means it's not shaded inside. So do you guys get that it would be shaded here and here? Okay, and you'd have a closed circle here and a closed circle there. Do you get why they're closed? Is because of this. Now this goes back to what Logan was saying. He said, when you go to say what x's it works for, you'd have two different things, okay? The first one here would be that x is less than or equal to, and this point is negative 2.87, so it's less than or equal to negative 2.87, and then you put a or, and this point is 0.87, so it'd be x is, what do you think it would be? Greater than or equal to, because you're going this way, of 0.87. Do you get that? Yes.
If it wasn't greater than or equal to, do you have to dash like the line that's on the x-axis?
No, you would just have open circles here.
So what do we shade?
Only the number line on this, only the x-axis.
If they're going this way, wouldn't you always,
Are you sure?
yeah.
Are we good? Okay, we have one last one, but it's very similar to this. Okay, so this one's gonna seem very much like this. So what we're gonna do is they're gonna ask us to solve an equation algebraically. And this we do not have to graph. Okay, on the first two, the first one we wanted a pretty detailed graph. The second one we just graphed minimum, maximum, and x-intercepts. Minimum or maximum and x-intercepts. This one we don't have to graph. What you need to do though is you need to find the x-intercepts. And you can do that by using a graphing calculator, which we've been doing. You can factor it if it can be factored. You can complete the square, or you can use your quadratic formula. Would you guys all probably use your calculator?
Yep.
Okay. If it looks easy to factor and you can do that, go ahead, but otherwise just use your calculator. Now this one I have to right away get the 18 over. So I have minus 18 is less than or equal to 0. And some of you might be good enough at factoring right now that you can factor that and get your zeros right away, okay? Let's go in and let's graph this. Let's go y equals clear. And we're gonna do x squared minus 3x minus 18 graph. And then in this one, I don't really care what's happening down here, so this is okay. I just care where these are. And if you notice, it does look like this one's right at -3, and this one's at 1, 2, 3, 4, 5, 6. But let's make sure. So we're gonna go second trace down to 0. We're gonna move our cursor so it is to the left. of that first zero. Move this to, so it's to the right, hit enter, and my first x-intercept is at -3, okay? So my x-intercepts, the first one is at -3. And if I go back here, I'm gonna go second trace again, down to the 0. I'm gonna move this. Whoops. Just make sure it's to the left of that second 0, hit enter. Make sure it's to the right of the second 0, hit enter again, and that one is at 6, 0. So my x-intercepts are at -3 and 6. Now, when they say to solve it algebraically, you're gonna solve and get your x-intercepts. And here we're just gonna use a number line, okay? So on your number line, you just have to put your two x-intercepts. You put your smallest one on the left side, your biggest one on the right side. And again, what you're gonna check is this is either gonna be shaded in between these two or on the outside parts. Okay, so it's either going to be in regions 1 and 3 or in region 2. All right. What I would do on this one, I would probably try a point inside here because isn't 0 inside here? Right? 0 is between -3 and 6. So let's try 0 in that equation. And if I do, I would get 0 squared minus 3 times 0 minus 18. Is that less than or equal to 0? Yes.
Do we need to like
No,
write all that out? 'Cause
No. because you can probably just do that in your head.
Yeah.
Oh, wait.
Would you use that equation or the original equation?
You could do either one. Yes, good question. So is -18 less than 0?
Yeah.
Did I say no?
Yeah.
I might have said no. Okay, so that one works, right? So do you guys get that it's going to be shaded here? What about these 2 points? Because that's important. Are they open or closed? They're closed, right? So when we do that solution set, you put the smaller number here, the bigger number here, x in the middle, okay? Always less than, and would I have equal to?
Yes.
Yes. This is your answer. So what do you think about doing we skipped the last page. I think I printed off an extra page that we aren't gonna do.
That's okay.
How do you guys feel about, do you need to see another one like
No.
this?
No, we're
You're good? Okay. So here, your assignment looks kind of overwhelming. Okay, so here's the deal. 1 through 3 are like the first 2 examples that you have to graph, like a pretty detailed graph. These on your sheet, I think if you guys look at maybe your last page, on here, it has this assignment, except if you look, notice it says 22 twice. So you would just scribble that second 22 out, okay? These are where you just sketch your graph, give the minimum or maximum and the x-intercepts. And then these is where you do your number line. So this is like the first 2 examples. This is like examples 3 and 4. And this one is like example 5. Does that make sense?
Yeah.
All right. So, and then tomorrow, I'm going to have a review assignment that if you do it and bring it for the day of the test, you'll get 10 extra credit points on your test. And then Monday is your practice test. Oh, does anyone need graph paper? If anyone is able on graph paper, grab whatever you'd like.
Yeah.